Hi, I'm Phil, and today we're going to explore large language models on the Raspberry Pi. And this is all part of AI, or artificial intelligence, that can be applied to different areas. So we're going to explore it on the Model 5, where there's enough RAM, because having a reasonable size RAM is important. We have to learn a little bit more about the Raspberry Pi. And the large language models, we're going to go through a few of them. The first one is Phi 2, Llama, uh, and they're the two ones that I'll be looking at. Mextral is another one, but the one that I'll be focusing on comes from Microsoft. And what's interesting about it is that Microsoft worked with OpenAI in the development of how you can use GPT-4. And they actually did a lot of their work prior to the release of Phi 2 in secret. Then after they released GPT-4, Microsoft got to work very quickly to commercialize. But Phi 2 is more of a research tool that is shared with the community. And that's the tool I'll be using today. I want to test the models, perhaps compare some of them, their performances. Would it be possible to use the AI accelerators I have, like the Google TPUs, and also the Raspberry Pi AI module? Could they be used for large language models? And while I use these for image recognition, I haven't seen very much how you can speed up the AI process. So the applications are mainly in things like chatbots and being able to have a series of questions and answers that exploit the world knowledge and view together with common sense language processing and being able to use language to understand what the other agent, which might be a human being, what they're talking about and what they want. Okay, so let's have a look at the background. So I'm going to use an inference provider, and the one that I'll be using comes from Hugging Faces. So if you get an account on Hugging Faces, you can have access to a wide range of models that can be quite useful, even in a Raspberry Pi setting. So the formats Q&A, will be conducting tests with Q&A, not so much with chats, but some of our tests will also do coding. That is, can my AI model, my large language model, is it possible to code in Python? So we'll have a look at that. An important thing about the Raspberry Pi, it's small in comparison. So while we talk about large language model, they really are small large language models. And the tool that helps us achieve that goal is called quantization. And that's a way that we can reduce the size of the model, which might have started off very large, into a much smaller format. And one of those formats is called GGUF format. And again, you'll be able to find the models in that format in the Hugging Faces. So if you search Hugging Faces, we might actually go and have a look at that now. So we're searching Hugging Faces for models that are in that format. And there are actually quite a lot of them. There's at least 100 pages there of models that you can work on. Okay, so the potential models, there are some of them. And what's important about the models is that you can change the precision of the model and you can select different alternatives depending on whether you have an 8-bit precision right through to a 2-bit. So there's another test that's needed, and that's to find if you get how your answers and how your interaction compares when you use different levels of precision. So the original model from Microsoft It was released in December 2023, and it was based on a previous model of 2.7 billion parameters. And they used quite a lot of textbooks. So while it has a bit of knowledge, it doesn't have the same extent of knowledge. That is, it doesn't have the Wikipedia, for example, but it does have lots and lots of textbooks. And they trained this model for 14 days on 96 A100 GPUs from NVIDIA. And if you go across to Microsoft Research, you can get some more background into the model. Okay, so I'm going to use the model that comes from Hugging Faces, and the base model that I'll be using, the size of the file is 1.5 gigabytes. So you can see it's actually quite a big difference from the 2.7 billion parameters to the file size after it's been quantized and in a format which is ready for the Raspberry Pi. So I'm going to carry out Q&A sessions, things like I'm going to ask a question, write a detailed analogy between mathematics and a lighthouse. So that's one that Microsoft have been using. Another one is it's going to do some calculations on the final velocity at the bottom of a slope that a skier has gone down. And the final one, because it's they considered coding to be important, we'll be looking at a Python function to print the first n numbers in the Fibonacci series. And we'll also have a look at a bit of higher precision. What happens if we go from our 1.5 gigabytes and we can actually change the bit size, and while that's larger, it'll be interesting to see what happens. Okay, so there are plenty of benchmarks. I'll be just doing a human evaluation to evaluate the results. Performance-wise, I'm interested in how the different models compare, particularly when I compare other models other than the Microsoft. And some of these I've got listed here. And there are models in the GGUF format. Okay, so that's a bit of the background. Hardware-wise, I'm going to use the Raspberry Pi Model 5. So the more RAM, the better. And I'm going to test it on a number of Raspberry Pis that I've borrowed from other people. And I want to see if I'm getting a consistent approach and whether it works on them. And the Raspberry Pi, the one that I'm actually using, not only has a Raspberry Pi, but it has on top of the Raspberry Pi an active cooler, which will keep the whole processor system much cooler. And I'm going to add a dual M.2 hat so that I can actually use the SSD 2.2 SSD for extra memory, which is a bit faster than just relying on the micro SD card. So reasonably fast. I probably could go for a generation 3 rather than a generation 2 and speed things up even further. So the important thing is to check with your Raspberry Pi how much RAM that you've got available. I found that one of the ones that was submitted to me only had 4 gigabytes rather than the 8, but I was still able to compile the large language model on the smaller Raspberry Pi. Raspberry Pis, I'll be using Bookworm. It's a Debian system, fairly recent, and there are some of the specs on that. 64-bit version, and it was released towards the end of last year. The libraries, it's not so obvious what the libraries are when I'm using them, but I'll go through the deployment and the compiling. Uh, so let's have a look. These are the files that I'll be using from Hugging Faces, and I'm interested to compare what DF Robot got with some of their performance measures. And they used things like the token speed. How long does it take to make a decision? And we're going to have a look at some of my sessions. So that's the software. And let's have a look at the projects. First thing was to compile these. And my desktop looks like this. I don't really need the accelerator, the AI accelerator. It's not contributing at all. And it's probably a good idea to get rid of it to reduce the heat load. But in any case, this is my arrangement on the Raspberry Pi. The other thing to note is that in a lot of the literature I was using, the lambda was used in association with the Pi, and it was a bit confusing. So I'm finding when I was downloading a lot of the models, they were, including the Phi model, it was under an LLAMA directory. So that can be a bit confusing, but it's not a big issue. So my objective, we might actually expand that a bit so you can see it, is to explore small large language models that can work on a Raspberry Pi. And I want to create an environment. So besides using Python, we really need to protect our models, and we're going to do that. We're going to compare the 4 gigabyte and the 8 gigabyte models, and we're going to compile and download the models. We're going to download the Microsoft models, and we'll actually have a look to see what they look like. So the one I'm going to show you, I've gone through 5 steps. So the first thing is that we create the virtual Python environment on the Raspberry Pi. And I'm not going to do this live, but these are the steps you need to make. The first step is really creating a new directory called my_AI. And that's where I'm going to activate that, and I'm going to download the files into that area. So go on to step 2, where I download the dependencies. And step 3, I'm going to download the model. So you might actually go across and have a look at that. So we'll go across to the website. Okay, so you can see one of the sources of where the Llama and the Pi came from was from this website. So while they do have many models in here, so you can go down and have a look at them. We'll just open them up. You can see they're in the format that we're interested in, and most of it is associated with the Llama. We're going to add additional models into this directory, but we have to download that first and transfer that to the Raspberry Pi. Okay, then we go through a build. We go into the directory of llama.c++. We're compiling everything, and we're ready to go. Then we'll do the tests. So the sort of tests that I've been working on over a couple of days are these ones. And we might go across, copy some of those, and just see what the results are. So since it was good at mathematics and coding, what we're going to do is ask a question, write a Python program to print the first n numbers of the Fibonacci series. So I'm just going to do, I'm just going to copy that, and we're going to go across to the Raspberry Pi. So we'll just get out of the mind map, and here I am on the Raspberry Pi. So I'm going to paste that in on the bottom. And it's going through preparing the model. And it's actually already answering the question and providing the Python code right at the bottom of the model there. So it'll be interesting to see how long it takes. Doing it reasonably quickly. Now, bear in mind, I've actually increased the size of this model and the precision. So there you are. It's done that all under 2 seconds is the load time. And overall, 26 seconds total timing. So there's actually a lot of text there, including performance data, but the important thing is the answer to our query. Okay, so let's go back to the mind map. And next one, I'm going to do one which is a little bit more in the language area. So we're going to ask our model, our Pi model, to actually do a detailed analogy between mathematics and a lighthouse. Okay, so let's copy that and we'll go across to the Raspberry Pi. So what I'm using here, my Raspberry Pi is on a program called VNC, and I'm able to access it from my PC. So we'll paste that in and we'll see what the result is. Question. So it's thinking about it. Answer. Just as a lighthouse uses a strong beacon to guide ships safely to shore, mathematics provides us with a set of tools and principles to navigate the vast sea of knowledge and arrive at accurate conclusions. This ensures that we reach our destination of understanding without getting lost in the tumultuous water of uncertainty. Now, I thought that was quite good. Good analogy. You could almost use that as part of poetry. Okay, let's go back to our mind map and see if there's any other models we want to try. Okay, so the next one's a mathematical model. Now, I think this is the one that it bombs out a little bit, but let's run it and see what happens. So we'll grab the model, and it's been framed in such a way that the question is embedded in the command for our Linux system. Let's go across and have a look, which is here. We'll put it on the bottom and we'll paste that in. So it's now given us the answer. Now it's a bit strange. I don't know why it's come up with alternatives. 50 meters a second. I suspect that it's got hold of some of the previous text from examination papers where they've had a multiple choice, but it's come up with the reasoning behind why it chose 50 meters a second. And you can see that it's talking about gravity and the relationship between mass, potential energy, and kinetic energy. It's giving us quite a detailed answer to that query. Not only the answer that we wanted, but a bit of a background behind it and how you could actually calculate the velocity. Okay, you might notice that when we posed the question, we didn't actually give it a mass. And it's continuing on. What a detailed answer, if ever there was one. Okay, so we're back to the prompt, and we'll go back to our mind map. The next series of questions I've been using on various large language models just to compare their answer. So we'll go to this one, which is how do I stay healthy? And I want some solutions for that. Let's go across. We'll type that in, paste it in. There's our question. How do I stay healthy? That's the question. The answer, of course, is to eat healthily. It's easier said than done. Many people do not know to eat right and end up eating foods that are bad for them, for their bodies. So I'm going to share with you some tips on staying healthy through proper nutrition. How do you cook vegetables? So it's giving you some tips to follow through. Um, and vegetables is one of the answers that it's given us. Then it's talking about digestion, about chewing your food, breaking the food down in the stomach, and make it easier for your body to digest. And it's also talking about probiotics, which is interesting. It's then talks about sugar intake, and the amount of sugar in drinks, and perhaps going for unsweetened beverages, and perhaps checking the label on the bottom. Quite a detailed answer to that query. Okay, so we might just see, it's talking about vitamins now, and they're all related to health. Although it's interesting to note that it doesn't actually tell you that there is a limit on the vitamins you should take. How do I maintain a healthy weight? And it talks about physical exercise. So it's actually talked about a number of parameters that relate to living more healthily. And it's going through heart disease. So you could actually spend quite a lot of time just reading the results. So it's got a good answer to that one. Let's go back to the mind map and see if we've got any other interesting questions. I've got one for hobbies. Who's the president? Now, this will be an interesting one. So what we might do is actually ask it who the president of the United States is, bearing in mind that it's not really a model for knowledge in the same sense that some of the other models are. So we'll paste the question. Who is the president of the United States? Then it tells us that it's Joe Biden. Now, that's interesting because when I ran this previously on a smaller model, it gave Barack Obama. Now, our model is ancient. That is, it's at least 6 months old, and it hasn't kept up with the change of the presidents. Let's go and see if there's any other interesting models. Okay, I might just do the last one, which is how do you make noodle? Now, I've compared this one with with Chinese models, where they're more used to making noodles, and we'll compare it with the answer they give here. So we'll go across and we'll ask the question, we'll paste it in, and we'll see what it says up for making noodles. Boil water, add salt, flour, and create a dough. That's actually going through all the instructions on making noodle. Not a big answer. If you did this with M5 Stack, the large language module, you'll get a much more detailed answer, even though it uses a smaller model. Okay, we'll go back to our mind map. Besides commissioning it to see if we're getting any answers, I've run some alternative models, and I won't go through all of those here, but these include doing things like, let's see if we can find, comparing. And as soon as the model got pretty big, the first two models were actually very large, 7.3 gigabytes for the cognitive on Mistral, which started off as a 24B and was compressed to a 7.3 gigabytes. Then DeepSeek started off as a 7B, and the size of the model was 6.1 gigabytes. So while it fits on the Raspberry Pi, it actually didn't run these models because it didn't have enough RAM. So it'll be interesting to know if I try to execute these on a Raspberry Pi with 16 gigabytes, will it run these models? And I also compared the Phi 2 with Q4 and also Q8, and I was able to run the models on those ones. Okay, so we might go and have a look at our references. Overall, I'm quite pleased that I was able to get that to work, which was really good. So, a very good source of reference is DGAP Robot, where I was originally inspired by their website. They actually have a good uh, description, and the steps that I took comes from their website here. Go and have a look at the Raspberry Pi, Hugging Faces, and there are lots of concepts. You can build up an understanding of deep learning, reinforced learning, what a generative model is as you go along, and find out what quantization is and how it influences. You can go across to the Microsoft research will tell you a bit about Phi 2, and even in the video, you'll be able to find out how Microsoft used their chips to train the model. Okay, so that's it from me. Uh, See you next time. Bye.